Hello, Year 8. Last lesson we learnt about the area of a circle, or a semicircle, or a quadrant even. If we had half of a circle, we knew that we put a half in front of our pi r squared. But what happens if we have a sector of a circle where we're going to be given an angle inside our sector here? So we're using the symbol theta to represent the angle. To draw that, it's just like drawing a zero with an extra little swirl on the top of it. It's a Greek letter, but it just represents the angle. So maybe you might have 40 degrees in here. That might be the size of the angle. We need to be able to adjust our formula. What fraction of the circle do we have? Now, if we know that there is 360 degrees all the way around the revolution, whatever that angle is, we put it over 360 degrees. So here's the formula. Theta over 360, that gives us the fraction, and then we times that by the pi r squared. So that's the formula for the area of a sector. We may, in this section, have some composite shapes, which means we're going to have, we've done this with rectangles and straight-sided shapes before, but we're going to have some circular pieces in there too. So we'll be adding some shapes together or maybe subtracting them. A special type of composite shape is an annulus. It has its own special name for one circle being cut out of another circle. So each circle has a different radius. So the radius of the big circle uses capital R. The radius of the little circle is little r. So the area of that annulus would be pi r squared, capital R squared for the big circle, minus pi r squared for the little circle. There is an or here. This second version has the pi factorized out the front, and then it's just the big radius squared minus the little radius squared. So I'm going to be using that second formula today. So in our questions, question number 1, find the area of the following sectors correct to 2 decimal places. First of all, the formula for the sector is A equals theta over 360 times pi r squared. The theta is this angle, the 60 degrees. The radius is going to be the 8. So in our second line, we're going to sub those in. 60 is the angle over 360 times pi times the 8 squared. In the calculator, we have our fractions, so we'll do 60 over 360 times pi times 8 squared is 33.51. And that will be centimeters squared. Part B, also a sector, so we're going to need our sector formula. A equals theta over 360 times pi r squared. This time my angle is the 41 degrees and the radius is the 12. Subbing them in. 41 over 360 times pi times 12 squared. In the calculator, 41 over 360 times pi times 12 squared is 51.52. And that will be centimeters squared. Part C is still a sector. It's just a very large sector. So we're going to write our formula down again. A equals theta over 360 times pi r squared. The theta is the 310 and the radius is 2. So 310 over 360 times pi times 2 squared. In the calculator, 310 over 360 times pi times 2 squared is 10.82 centimeters squared. Question 2 says find the area used by the windscreen wiper blades shown in the diagram below. Give your answer correct to 2 decimal places. So this here would be our windscreen wiper blade, and it is swinging all the way across to here and finishing there. So the windscreen wiper is that sector, this shape here, shape number 1, that is the windscreen wiper area that is being covered. So let's find the area of that sector with our sector formula. Theta over 360 times pi r squared. So the angle this time is 100. 100 over 360 times pi times the radius, which is 1.2 squared. Put that in your calculator, and to 2 decimal places, you get 1.26 meters squared. Part B says, what area of the windscreen is not cleaned? So the windscreen wiper is cleaning this shape 1 here, but all this stuff outside, all this parts, this is not getting cleaned by the windscreen wiper. So to find that area, I'm going to have to find the area of the rectangle and subtract off the area of the sector. So I'm going to call shape number 2 the area of my rectangle. The formula for the area of a rectangle is A equals BH. The base and the height of my rectangle is the 2 meters and the 1.5 meters. So it'll be 2 times 1.5, which equals 3 meters squared. So the area that is not cleaned is going to be the 3 meters squared that I worked out here for my rectangle, minus the 1.26 that does get cleaned by the windscreen wipers, which means that there is 1.74 meters squared that is not cleaned. Question 3. We want to find the area of each annulus. Now, the formula that we're going to use for the area of an annulus, it doesn't really matter if you use the other one, you'll get the same result, but I'm going to use the pi bracket, big radius squared minus little radius squared. So they do need to be a radius though. These measurements are both diameters. So the inside one here, with a diameter of 45, that will be the little radius. 45 divided by 2 is 22.5. The big circle has a diameter of 72, so that's going to be a big radius of 72 divided by 2, which is 36. Subbing those in, we get pi bracket, big radius squared minus little radius squared, close brackets. Put that in your calculator. So pi bracket 36 squared minus 22.5 squared. And to 2 decimal places, we get 2481.07 millimeters squared. Part B, same thing, it's an annulus. So our formula is A equals pi bracket big radius squared minus little radius squared. So the big radius is 18, and that is a radius because it's from the center to the edge. And the little radius is the 9. So we pi bracket 18 squared minus 9 squared. In the calculator, that will give you 463.41 centimeters squared. Question 4, this is composite shapes. Calculate the area of the composite shapes correct to 2 decimal places. As soon as you see the word composite, you're thinking that you need to chop this up into some pieces. For shape A, I'm going to chop this so that I have a rectangle and a half of a circle. So I'm going to say shape 1 is my rectangle, shape 2 is my half a circle. So my formula is going to be, first of all, my rectangle will be BH, And then I want to add to that my half of a circle, which is half of pi r squared. So this is shape 1, and this is shape 2. Okay, now we want to sub into those formulas. So the base and the height of my rectangle is 55 times 25 plus half pi r squared for my circle, so it'll be half, and then times pi times the radius squared. Now this 55 would also be up here, 55, because it's a rectangle, but that's a diameter. If I want the radius, I'm going to need to divide that by 2. 55 divided by 2 is 27.5. So it'll be 27.5 squared. Type that whole thing very carefully into your calculator, and you should get 2,562.91 meters squared. Part B, we already have a dotted line across here to help us split up our shape. So we have a triangle and half of a circle. So the formula, if I do shape 1 and shape 2, will be the formula for a triangle, which is half base times height, plus the area of half of a circle, which will be half pi r squared. However, there is a bit of a problem. I know the base and the height of my triangle, that's the 8 and the 4, because there's the right angle base and height with the right 8 and the 4. But the radius of my circle needs to come from this side, which I don't know. So I'm going to need to use Pythagoras' theorem to find the hypotenuse, which is that third side of the triangle. So let's do that up here. Hypotenuse is equal to the square root of a squared plus b squared. That's the formula. The a and the b will be 4 and 8. And then when you put that in your calculator, you find that the h is equal to 8.94 centimeters. Now that is the whole way across that semicircle, which means that that's a diameter. If I want the radius of that, I still need to divide that by 2. 8.94 divided by 2 is 4.47. So I had to do all that working first, and then I can put those measurements into my formula. So second line, A equals half times the base, which can be 4, times the height, which is 8. That's my triangle. Plus, now onto the semicircle, half times pi times the radius, which is 4.47 squared. Put that all into your calculator and you will get 47.39 centimeters squared. Question 5. Calculate the shaded area. We have a big outside square, so that's going to be shape number 1. And then we have a whole bunch of little circles here, 4 circles, but they're all the same size. So if I just find one of them, so this is going to be shape number 2, will be one of those circles, and I'll just have to times that by 4 to get rid of all 4 of those circles. So this is my formula. A for area equals the area of a square, which is s squared, minus the area of 4 circles. So one circle would be pi r squared. So 4 circles just means I want to times all of that by 4. Okay, let's sub into our formula. The side of my square is 7, so 7 squared minus 4 pi times the radius of my circle. The 2.3 is a diameter, so the radius is going to be 2.3 divided by 2, which is 1.15. So we'll put that in here, 1.15 squared. Type all that in and you find that the area of the shaded section is 32.38 meters squared. All right, your turn. Go to your workbook and do pages 25 and 26.